Good evening, my name is Brian Ruiz and this is my Bootcamp project number 4. The topic of my cybersecurity project is DVWA Insecure CAPTCHA. In this presentation, I will demonstrate the damn vulnerable web app and how the CAPTCHA can be compromised. First, let's define what a CAPTCHA is. A CAPTCHA is a program that can tell whether its user is a human or a computer. You've probably seen them, colorful images with distorted text at the bottom of web registration forms. CAPTCHAs are used by many websites to prevent abuse from bots or automated programs usually written to generate spam. No computer program can read distorted text as well as humans can, so bots cannot navigate sites protected by CAPTCHAs. CAPTCHAs are often used to protect sensitive functionality from automated bots. Such functionality typically includes a user registration and changes, password changes, and posting content. In this example, the CAPTCHA is guarding the change password functionality for the user account. This provides limited protection from CSRF attacks as well as automated bot guessing. DVWA instructions require us to change the current user's password and that we are a human, not a robot. First, we'll need to open our Guacamole virtual machines, open a terminal and enter the following command: cd./documents web-vulns & docker compose up. This command changes our directory to where the Docker file is located so we can run it. Next, we open up a browser, in this case Firefox, and enter the following IP address: 192.168.13.25. After logging in, we click on Insecure CAPTCHA on the left column. We immediately notice the red error message stating that the reCAPTCHA API key is missing. This indicates that the application is attempting to use Google reCAPTCHA for bot protection, but cannot find the required API keys in its configuration file. The solution is presented below and requires us to register for a key from reCAPTCHA. As a service, Google offers the ability to create CAPTCHAs for web apps. This generates a public and private key, which we'll see in a moment. We will enter DVWA for the field label. Under reCAPTCHA, we're going to select the challenge, v2, and default I'm not a robot checkbox. For domain, we will enter 127.0.0.1, which refers to a local computer you are currently using. This allows network services to communicate with themselves. After entering the required information and clicking the Submit button, Google will generate two keys. The first is the site key or public key, and the second is the secret key or private key. The two-key system ensures a balance of functionality and security. Once we've generated the keys, we need to insert them into the config file listed by the red error message. The red arrow shows the directory that this config file lives. We open a terminal and go to the directory where the config file is located. The first we open this directory the first time, there will only be one config file: config.inc.php.dist. More on that at a later slide. Notice that the directory is different from where we first ran our Docker and is located in the var directory. The command to open Visual Studio Code is code config.inc.php. In order to edit the file, we will need a code reader editor. I'll explain more about Visual Studio Code in a later slide. Now that Visual Studio Code has opened the config file, we need to look for where to insert the CAPTCHA keys. The white arrow indicates where the keys were inserted. Visual Studio Code is a lightweight, powerful, and free code editor developed by Microsoft. It is widely used by developers for writing, editing, and debugging code in a variety of programming languages and frameworks. This hack had many challenges. The next few slides we'll talk about them. Challenge number 1 was using the Visual Studio Guide in the first place. Because of this project, I learned about Visual Studio Code and what it can do. Although the process of downloading and installing VS Code on our VM was fairly easy, there was a learning curve in discovering VS Code in the first place since we had never used it before. The following are the commands used to install Visual Studio Code. The normal distribution of DVWA only includes the following config file: config.inc.php.dist. This is the second challenge. When the config directory was opened the first time, only the .dist file was there. It is necessary to create a new config file without the dist extension. This slide shows the Linux command for creating the config file without the .dist extension. Challenge number 3. While it might seem obvious to some, knowing where exactly to insert the keys was trial and error. I had to try all 3 places to see which one would work. Number 3 was the right answer. Challenge number 4. After inserting the keys, I tried to save the file in VS Code. However, while in restricted mode, an error shows that I do not have the permissions to do that. Retrying as sudo did not work. I finally noticed a trusted site button on the lower left that enabled me to save the file. After saving the config file, it's best practice to restart Apache so the changes that were made in the config file will take effect. This challenge proved to be the most time-consuming challenge. The slide shows the command for a typical Apache 2 restart in Ubuntu. It did not work, and I had errors. Sudo system control restart Apache 2 was supposed to work. As you can see here, using the command to restart Apache 2 failed and recommended that I use system control command to determine why. At the bottom right, you'll see the red letter reading code equals exited, status equals 1, failure. And I still don't know why it failed. To overcome this challenge, these were the strategies that I employed. Number 1, I decided to try the Oracle VM instead of Guacamole. Fortunately, I had downloaded earlier in the boot camp in case Guacamole boxes did not work. Unfortunately, Apache 2 would not restart on it either. Number 2, the DVWA runs on a PHP config file. I thought maybe the issue was with the config file. I went down a long rabbit hole in various bodies of knowledge trying to understand how PHP files work and how this file could be responsible for Apache 2 not restarting. But I was again frustrated with failure. Number 3, the last strategy turned out to be the best. I decided to download DVWA directly to my laptop using XAMPP, and I'm happy to say that it worked. Installing and configuring XAMPP proved to be a very long and somewhat complicated process, but I was thankful that there was a 15-minute YouTube help video for that. First, I located the GitHub for DVWA and downloaded the zip files. There was some additional extraction and copying of folders and files once it was downloaded, but it was manageable. Of course, it was still necessary to change the config files extension, as we did previously, and although it did look a bit different in a GUI environment such as Windows. After opening the XAMPP control panel, it was necessary to create a database. This was done by clicking the admin button that the red arrow is pointing to. On the bottom right is a screenshot of part of the config file as viewed on Notepad. It gives us important information about how to configure the newly created database and XAMPP. This arrow shows that the database was created using the information from the config file. XAMPP is a free open source software package that provides an easy way to set up a local web server environment on your computer. It is widely used by developers to test and deploy web applications locally before deploying them to production servers. XAMPP bundles essential components needed to run web applications, making it easy to host websites locally, develop and test PHP-based applications, and manage databases using MySQL and MariaDB. Using the XAMPP, I was able to create the CAPTCHA. And here's a video of me solving it. And once we've refreshed the page, here we have the CAPTCHA. I'm not a robot. Change. You pass the CAPTCHA, click the button to confirm your changes. Password changed. DVWA insecure CAPTCHA solved. And once we've refreshed the... Now, submitigations. Some mitigations: we wanted to adopt a reliable CAPTCHA service like Google reCAPTCHA. It would be very helpful to use HTTPS instead of HTTP. Rate limiting and IP blocking. What you would do is implement rate limiting to restrict the number of requests from a single IP address. Implementing CAPTCHA variants, where you would rotate between different CAPTCHA types, those examples listed, to make automation more difficult. To combine CAPTCHA with other security measures such as two-factor authentication, device fingerprinting, or session-based validation. Test and regularly update, of course. Conduct security assessments to ensure the CAPTCHA is. On a personal note, I've learned a great deal about success and failure because of these challenges, and it's worth noting that in order to be successful, cybersecurity professionals must possess tenacity and grit. Like many of you, at times I felt like quitting, but did not. So congratulations to all of us for getting this far. Not all of our hacks will be successful, but we must be successful and never giving up. Thank you very much.